All right, you made it to week 6. So this week we're going to work on a couple of tasks. So today we're going to talk specifically about density as it applies to, the density of a particular object and also population density. All right, so you want to be able to calculate density of each of those. Usually they'll be real-world objects. All right, so first a definition. What is density? So you probably learned it in your science classes already, but I'll just put it here. So we got density is the amount of matter that an object has given, a certain amount of space or volume. So we would say the formula is density equals mass divided by volume. So I just say density equals mass divided by volume. Now those other three formulas are correct as well. It's just that I use this one the most, and then if I want to figure out the other, formulas, all you have to do is just a little bit of algebra. So if you wanted to solve for m, then you just multiply both sides by v, and then that will give you density times volume. So any of the other formulas you can get. I just like to, have one formula memorized. Density equals mass divided by volume. All right. So next thing, let's go ahead and utilize that formula. So we have a couple pieces of wood. They are logs, and they're Douglas fir and American redwood. So we're going to try to figure out which of these pieces, which of these logs is actually more dense. So see if you can make a prediction, without actually calculating the density. Which log do you think is denser? Or you could say more dense, okay? So maybe you'll pick the one that has more mass, whatever, and then I'll give you a second here to think about that. All right, so maybe you paused it so you could think a little bit more. All right, so now we're going to go ahead and we're going to calculate the volume first of each log. Keep in mind the logs are in the shape of a cylinder, and so we can use our formula for a cylinder. Remember when we were doing volume of different objects? So volume of a cylinder is just the area of the base and then times the height. So the area of the base is a circle, so it's pi r squared, and then times the height. So let's do this first object. So it's a Douglas fir, so I'll just say it's the DF, okay? So the Douglas fir. Okay, so it's going to be volume equals, it'll be pi. Now the radius of the Douglas fir isn't given, but the diameter is, and we know the radius is just 1/2 of the diameter. So we're going to say 3, and then we're going to square that. And then we're going to need to figure out the height. Well, they have the height given to us, so that's going to be 17. So we just multiply those together. So I'm going to do 3 squared, which is 9. 9 times 17. So I get 153, and that's pi. And if I was including my units, then that would be cubic centimeters. All right. Next, let's take a look at the American redwood. So the American redwood, it has a radius that's not given, but the diameter again is given, so the radius is just half of that. So that would be 4 squared, and then times the height, and the height is given as 12. So we're going to say volume equals, and we got 4 squared, so of course that's 16, so 16 times 12, so 192 pi. All right, so we have both of the volumes. So now let's calculate the density. So let's do the density of the Douglas fir. So density is always going to be the mass divided by the volume. So the mass for the Douglas fir was given as 254. So that's 254, and that's kilograms. And then the volume is 153 pi, and that's centimeters cubed. All right, so I'm going to go ahead and just do the math on that one. So that's going to be 254 divided by 153, and then times pi. So I got let's see, I got 0.50, I'll round it to the nearest hundredth place. So I'll say 0.53, and that's kilograms per cubic centimeter. All right, now let's do the American redwood. So that one is going to be calculated by figuring out the mass. So the mass is given up there, 271, so that's 271 kilograms, and then divided by the volume, so 192 pi, and that should also be cubic centimeters. Should have put that in there. Okay, and then let's go ahead and just do the math on our calculator. So I do alpha y equals to make it a fraction. So then 271 divided by 192 times pi. That gives me, I rounded it to the nearest hundredth, so it's 0.45, and that's kilograms per cubic centimeter. Now you can tell which one has more kilograms per square or per cubic centimeter, and it's the Douglas fir. Has more mass per cubic centimeter, so it's more dense. All right, so let's look at population density a little bit here. So, the fire marshals are really concerned about this, population density, because they don't want the restaurants to be too crowded or the stores to be too crowded, so that if a fire or anything happens, that people wouldn't have any trouble, getting out in an orderly fashion, and so nobody would get stampeded or whatever. So it's super concerned about that, they are. The other ones that are really concerned about the population density nowadays are the CDC, and now, of course, the governor's following the CDC guidelines. Everybody has to be 6 feet apart. And even when the restaurants open up, whenever that is, in a month, week, whenever, 2 months, who knows, when they open up, they're going to still have to abide by the CDC regulations. So that's going to change the population density, really, of all of these restaurants and even the stores, etc. So it's going to be really interesting, because they won't be able to have very many people in the restaurant eating at the same time. So yeah, super interesting. And that all really deals with population density. All right, and we saw, New York, got hit the hardest with COVID-19, and it's because, there are just so many people packed into such a small space, right? And you can see there the estimation for the number of people, and then actually has the density. So the density is 27,751, at least at this time, people per square mile. Can you imagine that? That many people per square mile. And they're able to pack in like that, obviously, because they have these high rises, and, they're not just on one floor like a lot of us are, or 1 or 2 floors like we are. There are just so many floors. So just so many people packed into such a small space. So it's really not hard to, understand how the COVID-19 spread so easily in New York and how it continues to spread. All right, so let's look at how we actually calculate population density. So population density is defined as the number of people there are per amount of area that you have. So number of people divided by the area. That's a really simple calculation for population density. So let's say we've got this city. It's Burlington, Vermont, and we know that the area of this particular city is 160 square kilometers, and there are this many people in that particular city. So population density, so we would say population density, really simple. We just take the number of people, so 109,000. We divide by the area. The area is given as 160 square kilometers. I should put people on the top, and then you just divide that and you get some, decimal. And so let's go ahead and do the math on that one. So 109,000 divided by 160. So we would have, I got a fraction there, I'd like to get a decimal. So I have about, this is about 681, well, it's 0.25, people per square kilometer. So obviously this is equals, and so I would say that it's about 681, approximately that many people. 681 people per square kilometer. Okay? Now let's say that we weren't given the New York's, number for how many people that it is in square kilometers, and we had to convert it ourselves. I want to go ahead and show that conversion because you do a lot of conversions of different units in science, and I think it's great to be able to do that real easily. So let's kind of take a look at how we would convert that if we wanted to compare the city of Burlington versus New York and say, hey, okay, 681 people per square kilometer, how does that compare with the 27,000 people there are per square mile in New York? So let's try to make this one into miles, all right? So what you would do is you would start off and you'd figure out, of course, what the conversion is. So I just looked this up, just a quick Google, and you find out that 1 mile is equivalent to, oh, I did the opposite. So I did 1 kilometer is 0.62 miles, so that should work. So what you do is you start with what you have at the beginning. So you have 681 people per square kilometer, and then you can put a couple little spaces for fractions. These are going to be things you're going to multiply by. They're called conversion factors. And then at the end, you put what you want your goal to be. So I would love for my goal to be the number of people and then per square mile, so that I could compare really well with the New York, density, population density. So when you're putting a fraction here, you're like, okay, what do I put here? So this conversion means that exactly what it says, and it's hard to know. You have to write this as a fraction, so you have to figure out which one you want to put on the top and which one you want to put on the bottom. Now, I want the kilometers to cancel out, so I'm going to put 1 kilometer on the top, and then I'm going to put the point, it's not writing too great. So it's 0.621, why not? I'll just put them all. Okay, and then that's going to take care of one of the kilometers, but it's still going to be kilometers on the bottom, and I want to get rid of the kilometers. So I got to do that again. So I'm going to say 1 kilometer is equal to 0.621371. And see, I'm allowed to multiply by these fractions because they're the same thing as multiplying by 1. When you multiply by 1, it doesn't change the quantity at all, because these are equivalent to each other. So now I can cancel the kilometers, and then on the bottom, I should have put miles for both of those. So miles. So now when I multiply those together, you can see that I would have miles and miles, and so that would be miles squared on the bottom. And then on the top, I just have people. So the units are perfect. And then what you do is you just multiply straight across. So 681 would multiply with each of these numbers. So then that's just 681. So then it would be 681 on the top. And then you would multiply these two numbers together because those are the only two numbers on the bottom. So then it would be 0.621371, and then multiply it by it again, or just square it. And so I got like 0.3861 about. So I'm going to say this is about, I'm going to do 681 divided by 0.3861, and I get about 1763. And and it's like 0.79. So this is how many people there are per square mile. So I'll just put this little, so people per square mile. So compare that with New York. Isn't that just crazy how much less dense it is in that city? Look at how many times greater that is. So if you want to figure out exactly how many times greater, you could just take this number and put it over this number, and it would be that ratio again to tell you how many times greater it is. Cool, but definitely way, way less dense than New York. Okay, sometimes they'll have problems where you have to figure out the area. It's not like totally given to you. So I just wanted you to be able to do something like this. Whatever the shape is, you can just use your skills and figure out the area of that shape. So if this one is, let's say, just a nice triangle, then you can just find the area of the triangle. So you could just do area equals 1/2 base times height. So you could do 1/2. It looks like the base is just 100 right there, you can tell. And then it looks like the height, let's see what this is going up by. So 100, 1, 2, 3, 4, 5. So it's going up by, it has little tick marks of 5, so it would have to be going up by 20. So this would be 120, this would be 140, this would be 160, and this would be 180. So that means the height of this particular triangle would be 180. So the base is 100 and the height is 180. So then we can just calculate that. So multiply those together. So I would just say 50 times 180. So 9,000. So 9,000 is the area. So then if we wanted to figure out the population density, then we can just take the number of people. So it looks like the number of people is given there, this big number here. So over 1 million people for this particular territory. So we take this number of people and we divide it by this number, and these are square miles. So 9,000 square miles. And then we can just do the calculation and get a little approximation there. So let's see, I got 1, 3, 2, 3, 4, 5, 9, and then I'm going to divide that by 9,000. So I got about 147. I'm going to say approximately 147 people per square mile. Wow, so that's not very dense at all. These people are really spread out. So this is just that's the whole state. So pretty spread out compared to the density of the other spots. Yeah? Okay. So I think we might be pretty good on the density, 2 types of density. And then there's also this week a Fishtank problem. And we're just going to have you basically, use your good problem solving skills and figure out, how to do it. These are just a couple of hints. So you can read these, just pause it and kind of read the hints. I know you guys can read, so it won't be any help for me to just read through them. And then, just last a little bit, maybe of humor. So I know you guys always give 100% at school. It may be just a little split up between the days, but this is kind of about how it is really nowadays, especially as we're getting near the end here. But I really appreciate you guys hanging in there and giving good effort to finish out strong. All right? And then this is just me getting ready to go to the store. It's my turn. It's like what's that movie? Now I forget what it's called. Oh, booger. What is that called? I'm blanking. It's called... What's it? Okay, I remember. Hunger Games. Okay. So have a great week, and that's it.